Hello, my name is Ian Ryan, and I'm an AWS Cloud Architect and Engineer. Today I'm going to be continuing my Gen AI series, talking about a generative AI email spam filter. So if you want more details about this, you can check out my blog on ianchristopherryan.com. You can reach out to me on LinkedIn, or if you have any comments about this specific video, you can comment on YouTube. So let's get into it. The spam and phishing attacks are on the rise. I think we've all seen this. Even me personally, in my personal email account that I've had for about 20 years now, you can start seeing that there is like a lot more spam. I'm getting hundreds of spam messages and phishing messages every day. And most of these are being picked up by my email provider, but quite a few of them are starting to get through now. A lot of this is going to be because the spammers and the phishing attacks are actually getting more advanced, so they're actually managing to bypass existing filters. There has to be a better way, and there is. But I think first we need to understand what are these current methods that are being used to detect spam and how they're being implemented. The most common method is using machine learning. This is when you get a large data set of labeled email messages that are labeled as spam or not spam, then you train a machine learning model. This can then be made a bit more advanced because we can have neural networks, so we can actually start looking in a bit more depth at the email messages that come in. We can try and analyze the content and associate the context with which they have been sent and try and extrapolate from that whether or not it is a spam message or not a spam message. The other side of this, we can do more generic things. So we can actually start looking at common phrases that get used in spam messages or suspicious links and attachments. We're going to start looking at the attachments themselves, look at images, look at the content in them, look at the hyperlinks that have been attached from that email. And using these, we can then extrapolate whether or not this is actually going to be likely to be a spam message. On top of that, we can start looking at reputation-based and behavioral filtering. So this is about the reputation of the sender. This can be as simple as the IP address which the sender sent from has been blacklisted or listed as a common IP address that sends spam. Or else, much more commonly these days, we can start looking at DKIM and SPF and actually authenticate that the email actually came from the domain where it said it came from. In addition to this, many email providers now will track user interactions. They'll track how a user marks a particular message as spam. Do they open it? Do they move it from the spam folder into the inbox or the other directions? And all of this information is then used to train the machine learning models that we previously talked about. Finally, in addition to this, we can also get crowdsourced data. So we can get massive lists of known email addresses that generate spam, and then we can discount any emails that come from these. However, all of these existing methods have a lot of challenges with them. It is hard to keep these models up to date. That is why on the previous slide we were talking about tracking user interaction and essentially getting your user base to label the data sets for you so you can start training the models using those new data sets. But this is a continuous need for this. You have to keep on doing this to keep up to date. Not only this, the spammers are doing the same thing. So the spammers are building new models to try and bypass these new filters. The filters have to be constantly adapted. This is why on the previous slide we were saying that the users have to keep on labeling all of the data. They have to keep on flagging it whether or not it is spam or it is phishing. And it's this user interaction, which is also a problem because users can now mislabel things. If they mislabel a non-spam message as spam, it's actually going to make the machine learning algorithms worse. In addition to this, there is now an expectation on users to identify the spam themselves, identify phishing emails. And a lot of this comes down to companies pushing this onto their employees, where they want to put the responsibility of identifying spam onto the employees. And this usually turns into costly training programs. What's the solution to this? Well, as we can get from the title of this video, we're going to start talking about a generative AI-based spam filter. What is different about this? Well, first of all, we're not going to train anything. We're not going to do any training at all on this generative AI. We're just going to use an existing base model and ask the base model to identify if something is spam. Why will this work? Well, this is going to work because in the same way that when a human looks at an email message and they can recognize that looks like spam, models like this can actually do the same thing. They'll actually understand what spam is from a conceptual point of view, and therefore they'll be able to identify if it is a spam message. This can be more cost effective because we don't have to train our staff to identify these things. We don't have to have expensive machine learning models running. We don't have to continuously train them, which is where a large amount of the expense comes from. Before we actually build this, we should check to see how our model is going to perform. Is it even worth building? And so we do this in a few different ways. Essentially, what we need to do, like for any machine learning model, is we need to build a data set. So we need a large data set which has lists whether or not an email is spam, whether or not it is not spam, and then we need to feed this into our model. When we evaluate this, we're able to get a number of statistics out of it which show us how our model is performing. We start with precision. So this is how many of the emails are classified spam are actually spam. We have recall, which is how well our model can actually identify these spam emails. We have accuracy, which is the overall measure of the model's performance. So this is how well it is performing at detecting spam. And then we have an F1 score. Now, the F1 score is a single metric that is very commonly used in machine learning because it balances both precision and recall. It's especially useful for unbalanced data sets. So this is when we have in our data set a large number of emails that may be not spam and less that are spam. Very helpfully, Amazon Bedrock has a solution built in for doing model evaluation. To do this, you just need to provide a labeled data set. You need that data set that says, is this spam, is this not spam? And then you're able to feed that into these Bedrock or these automatic evaluation tools. You get to select a model and it will run and evaluate some of those metrics. So depending on the type of automatic evaluation that you select, you'll get different metrics out of it. We're going to be using the question and answer type, where essentially we are asking a question and we're expecting a specific answer. This would actually generate an F1 score for us directly, but it will also generate everything else. A very important thing to note, as with any of these automated tools, when you're doing machine learning, you should use this with some care unless you want to build shock. This is because what this tool is going to do is going to take in your large data set and actually run it against the models. Do you have 10,000 example emails? It is going to run 10,000 queries against that model. And once you're testing against multiple models, these costs can start adding up very quickly. Firstly, to make this work, we need to build a labeled data set. To build this, what we are going to do is we're going to download a large number of data sets. So there are a large number of existing spam, not spam data sets available online. A lot of these are quite old, some of them are newer, but we're going to download many of them and build a large data set to actually evaluate this model. We're also going to combine this with recent examples of spam. For example, my current email provider is categorizing large amounts of the email messages as spam, and it is doing it relatively successfully. So we'll also take all of that as input as a current data set. All of these entries are then saved in a JSON line format, and the format is essentially a prompt and a reference response. The way we're structuring it like this is so that when it is sent through Amazon Bedrock in the evaluation job, this is how it is going to evaluate it. It's going to send a prompt through saying, is this spam? And here is the email content. And then we're going to say in our label data set, well, we know this one is spam, so we'll say it should say true. When we run this model, after a not insignificant amount of time, the results of the jobs are available. This can take a while. This can take half an hour to an hour, depending on the size of your data set. If you're doing, in my case, 1,000 or 10,000 email messages to evaluate your model, this is going to take up to an hour. The results of this in our question and answer automatic evaluation is actually going to give us the F1 score directly. But in addition to that, it's also going to generate a JSON file, and this has the detailed results. And so we can actually parse that JSON file ourselves and then generate all the precision, recall, accuracy, and F1. And we might want to do this just so we can see all the different values rather than just a singular value that Amazon Bedrock is going to return to us in this evaluation. In addition to this, this also can be run across multiple models. So in our case here, we're running it across Claude Sonnet 3.5 and also Claude Instant. You could, of course, run it across any models you wanted, and there are many to pick from. So we just picked these two as it was a nice comparison of a very recent one with the Claude Sonnet and a faster and technically cheaper model, which is Claude Instant. How did it perform? Well, surprisingly well. The most surprising thing here is how well Claude Sonnet 3.5 actually did. We ended up with an F1 score of 0.978, which is really high. It is showing that our model is working incredibly well for detecting spam. And unsurprisingly, the faster but less advanced models, such as Claude Instant, did not perform as well. And that's understandable. These are a lot cheaper models to run, but they are less advanced than the more complex ones. It's also good to remember at this point here, we did no training. These are just the base models, as is, just evaluating when we give it the raw email content, is this spam? Since this all seems to be working really well, we can build a full solution in AWS now. This is the solution that we're going to build. Essentially what happens here is we're going to use simple email service at the start. Well, actually, we're going to have Route 53 as our starting point here because we're going to define our domain name in that. So we define our domain name in Route 53, and then we set up SES. But this is going to work. SES is going to receive the email messages. It's then going to drop the original email into an email archive. This is just so that nothing is ever deleted. And then the email is going to be sent through to Amazon Workmail. But Amazon Workmail is a managed service that lets you do email similar to other providers. It will give you like a web interface, so you have an inbox and you can actually see send and receive emails. In our case, the messages that are received by Workmail are going to be intercepted initially and processed by Lambda. The Lambda is then going to call out to Bedrock, which is going to evaluate whether or not this is spam. And if it is spam, it's going to bounce that email and it's going to send a response saying it was bounced. If it's not spam, it's going to deliver it. Let's look at the parts of this. First up, we have the Amazon Simple Email Service. The way that this gets configured is we need to create an identity. We do this just by specifying the domain name that we created previously in Route 53. This makes it very simple for us to set up an identity. Once the identity is being set up, we're able to enable email receiving. We're able to receive emails as well as send them using SES. In our case, we will add a rule set, and then we'll add a rule that will send the email to the archive S3 bucket that we wanted to do. For the Workmail integration, Workmail itself will actually create the rules in here, which are needed for its integration. With Workmail, when we create our organization, we do the same thing again. We point it to a Route 53 domain, and we create our organization. This actually links up automatically with SES, and we'll create a rule, which you'll see in SES, which passes the incoming email messages through to Workmail. Once this has been set up with your organization, you'll have a URL that you can go to get to a web portal to actually see your inbox. As I was saying, within Workmail, we are then going to create our inbound rule. The inbound rule is what is going to intercept all incoming email messages and then perform an action. In our case, we're going to run a Lambda function. The Lambda function we selected is going to be our spam filter Lambda function, and we're going to make this synchronous. This is so that the email will not be delivered until the Lambda function returns an action. In our case, it's going to be to either bounce it or to deliver it. If for some reason our Lambda function timed out, we've configured it here for after 5 minutes, it's just going to deliver the email. The Lambda function we've defined, our spam filter Lambda function, what this does is it reads the full content of the email message. So it connects to Workmail message flow, extracts the message ID, reads the full original content, and then passes this through to Bedrock. It combines this with a prompt, so the prompt will say, is this spam, essentially? And it will include the full raw content of that email message. So everything, including all the headers and all the actual content, including the body of the email message. Bedrock will then evaluate, is this spam? And it will return us yes or no. And then the action from the Lambda function is passed back to Workmail. So it's either going to say bounce it or else deliver it. Next, let's do a full demo of this. What we're going to do is we're going to send an email to our new Workmail account and to our new domain, and we will send an email which is normal, and we'll also send an email which is going to be spam and see how it handles it. Let's get into that now. Right, so let's have a look at our demo and see how exactly this has been set up. First up, let's look at Amazon SES. This is the email receiving part of it, where we're going to set up our rule sets and our initial test rule set. In here, we have two different rules. The first rule is going to be our test rule, and in this case, this is the one that is going to just deliver to our S3 bucket. What happens here if we look in our S3 bucket is it is just archiving every email message that has been sent to us. It simply stores them here in their raw format. Then if we go back to our test rule set, we can see we have this other rule that has been created. Now this is a rule that was created by Workmail when Workmail was configured. If we move over to Workmail and have a look at how that's been set up. In our settings, we go over to inbound rules. And here we have our inbound rule, which is going to apply to every email that has been sent to us. In this case here, it is just going to execute our Lambda function that we have called our spam filter. Let's look at that now. Here is our Lambda function. This is relatively simple what it is doing. Initially, it's going to set up its different client connections. And then the first thing that it needs to do is it needs to get the actual body of the email message. So not just the headers, it needs the actual full body because we want to send the entire body, including all the headers, to Bedrock. Once we have that content, we can actually call through to Bedrock. When you get the response from our evaluation, we are either going to bounce this or we're going to do the default action, which means to deliver. The actual call to Bedrock is pretty simple. We build up our prompt, and our prompt is going to be essentially, is this spam or not, and then include all the content. And then we call through to Bedrock and we get a response back. And if that response is true, we say, well, that was spam. Let's see how this works. We will compose a new message and we will send it through to our Workmail account. We'll send a simple message, which is clearly not going to be spam. Say this is a test. And then we'll just add some content as well. And we click send, and that has now been sent. If we go back to Workmail now, we see our message has been delivered, as you would expect. That is our test message, which has just been delivered. Let's go back again, and this time let's compose another message. Sending it through the same place in Workmail. And this time, let's make it a bit more like a spam message. We'll paste in all of these random links. This is clearly looking very spammy this time. And now we'll send it. What is happening now is that mail was sent through to Workmail. It is being sent off to Bedrock, same as last time, except this time it is going to evaluate it and no doubt identify that it was spam, and it will come back. It came back with our bounce message, essentially saying that this is undeliverable. And of course, if we go look at Workmail now, we will see that the message wasn't delivered. That's it for the solution. It's pretty simple to demo, but it works surprisingly well. So, some final thoughts. Well, the most surprising thing about this for me was how well it worked. Usually with these Gen AI solutions, they work pretty well. And you kind of go, that's a nice proof of concept and it works reasonably well. This one worked really well. It was incredibly accurate. And with a little bit more work, this would be like a very practical solution to actually filter out a large number of spam or phishing emails. Saying that though, I feel like this is more of an additional layer that you would add to your security posture in a company. It's more like you would add this as an additional layer so that there was just a bit more protection for all of the employees in your company. Another thought I had is that we could actually detect more than just spam or phishing from this. You could improve your prompts because it is now essentially scanning all of your emails that are coming in, but you could also make it scan all your emails going out. You could start detecting for things like potential data leaks. You could even detect things like non-business related messaging if you so wished. That's it for this video in this Gen AI series this time. There'll be more of these every couple of weeks as I record them. If you're interested in this, please make sure you subscribe and follow on YouTube. Also, feel free to follow me on LinkedIn and also check out my blog where there is a lot more details. about how this is actually all put together. Thanks for watching. Until next time.